Okay, so first things first. What we're doing in chapter 6 is we're going to be looking at normal distributions. What that means is symmetric. If you think back to when we did our histograms, that's where the tallest bar is in the middle and then it goes down symmetrically on each side. One thing you might want to do is read through chapter 6 in the book to kind of get an idea, especially look at page 299 through 301, and that will give you a better idea of what we're doing here. So when we have these, what we're doing is we're going to have our mean in the middle, and then we're going to count by our standard deviation. And my floor here really does not work. So we're not going to worry about that. So let's say our mean is 100 and our standard deviation is 5. Okay, so we have a set of data here, and those were the calculations. So what we're going to do is we're going to make a new number line so that 100 goes in the middle, and then we count by fives. And we did do this back in chapter 3 when we looked at Chebyshev and the empirical rule. So that's what it's going to look like, and then we're going to have a curve, something like that. Okay, so this curve will work for this number set only with the mean of 100 and a standard deviation of 5. But what if all of a sudden I have a new set of data whose mean is, let's say, 70 and standard deviation is 3? What I'll have to do is I'll have to draw a whole new graph. So I put 70 here, and then I have to count by threes. And then that's going to have that same curve. So I could do this for every single data set, no matter what the mean and standard deviation is. Well, what we want to be able to do in chapter 6 is answer questions about it, like what percent of students should score above 72, let's say. Well, in this case, we don't know how far away 72 is. Or let's say we want to know what percentage of students will score between 65 and 75. Again, we can do that with this one, but then we need to do a whole new set of numbers if we were to use the top set again. So what happens in chapter 6 is we look at something called the standard normal distribution. And what that does is it scales down every single data set, no matter what the mean or standard deviation is, so that your mean is always going to be 0, and your standard deviation is going to be 1. Okay, so we will be able to answer these questions based on this standard normal distribution that we're going to look at, because we compare every single mean and standard deviation that we have. We compare it down so that the mean is 0 and the standard deviation is 1. All right, so when we look at your actual notes then, sorry, I know this is really hard to see, but I can't get my camera to flip around, so we're just going to have to go with it. So a standard normal distribution is this. Your mean is 0, and your standard deviation is 1. Okay, and again, that is just so we can answer questions about every single distribution that we want to answer questions about. So when we look at, this is what it's going to look like. You're going to have your 0 here, 1, 2, and 3, -1, -2, and -3. This is going to be your z-scores or your z-values. So clear over here, this is 3 standard deviations away from the mean, or this is 2 standard deviations below the mean, so on and so forth. But again, we know not everything is just 1. We could have 1.6 away, or sorry, 1.6 away, or -1.2 away, or anything like that. Okay, so that's what we're going to have. So 6.1 is just showing you how to use the standard normal distribution. 6.2 is going to hopefully make more sense when we put actual data values and data sets with it. Okay, so what we have to do is when we get to 6.2, we're going to have to do something called calculate the z-value or z-score. Every class I've ever taken has called it the z-score, so that's what I'm going to probably call it more often than not, is the z-score. And what this does is this tells you how many standard deviations away a certain data value is. So if you think back to that first one when I said we had a mean of 100 and a standard deviation of 5, the number 110 would have a z-value of 2 because it's 2 standard deviations away. 95 would have a z-value of -1 because it's 1 standard deviation below the mean. So your z-scores will be positive or negative. Okay, so here's how you figure them out. Z equals x minus mu over sigma. So I know that's really hard to read. You'll have my printed copies that you'll be able to see. I'll make sure I post those also so you can look at those. All right, so x is the number they're going to ask you about. Okay, again, we're not going to actually do this until 6.2. But if you think back to what I was talking about with 100 for your mean and 5 for your standard deviation, I said 110 would have a z-score of 2. That's because 110 minus 100 is 10, divided by 5 is 2. 95 minus 100 is -5, over 5 is -1. So it's very important you put this in the right order. Okay, so mu is the mean they give you, x is the number they're asking about. Okay, so what you're going to do is you're going to need to print off this, what is called a z-chart or a z-table. Okay, you'll find this in the Chapter 6 folder in the file section. Okay, so this is going to be super important. You're going to use this from now all the way till the end of the trimester. So print this off and use it. So here's what this says. It says find the area to the left of z equals 2.06. So every time I do these problems, I draw myself a picture. Okay, don't mind my books here. So picture would be just a curve, and obviously it doesn't have to look good. I usually put a line in the middle, and that's going to represent, again, your mean, which is 0. Every single problem is going to have a mean of 0. And then your z-score that we're asking about is 2.06. We want the area to the left. So I shade what they're asking for. Okay, here's what's really cool. The reason we use this is because this whole area, the whole area under this curve is 1. Okay, so that whole area is 1. So what we're going to do is when we get to section 6.2 and later on we're going to ask for probabilities. So those are actually going to be percents. Actually today is going to be probabilities also. So you can do percents, or you can just, the area is going to be the decimal because it would be less than 1. Okay, so, and those of you who have taken calculus, you can actually calculate this. This curve has an equation, and you can find the antiderivative of it and plug in the numbers and you'll get 1. So I think our book does talk about it. We don't have to do it though, but those of you that took calculus, you would actually be able to calculate and prove that this area actually is 1. Okay, so anyway, back to our picture. The left of 2.06. So you'll notice this is 2 pages. Normally I would print it front and back for you, so if you want to do that, you might want to do that. One of them has negative z-scores and one of them has positive z-scores. Okay, so here's what I want you to notice. The picture that we drew right here matches this picture right here. The shading is to the left and the shading is to the left. So when this picture matches exactly, you're just going to look it up in the table. So here's how it works. 2.06. Along the left-hand side, you need to do 2.0, so right here. Then across the top, even though it says 0.06, this 0 and this 0 up top are the same ones. Okay, so you're going to do 2.0 and go over to the 0.06. It's right there, 9803. So 0.9803. Okay, so whenever you look it up on the table, they give you that amount, which is 0.9803. So that's your answer for this question. Okay? So let's look at another one. This one we want to find the area to the right of negative 1.19. So I'm going to draw my picture. And again, you don't have to do this. Some of you will decide you don't want to do it. I will tell you that on the chapter 6 and 7 test, the very first 2 questions you have to draw and shade. So you'll probably want to practice it. I still do it every time. Okay, so this time we want it to the right of negative 1.19. So when I draw this, again, that's going to be 0 if you want to write that in there. You don't have to. It doesn't have to be drawn to scale either. Negative 1.19, and we want the area to the right. So our picture is going to look like that. Okay, so when I look at my negative z-scores, negative 1.19, negative 1.1 all the way over to 9, but here's what you should notice. This picture doesn't match this picture. Okay, this chart always gives you the area to the left of whatever line you draw. We want the area to the right. So normally this is where I would make you figure this out on your own, but I'll just have to tell you instead. What's cool about this is it's symmetric. So the area to the left of negative 1.19 is the same as if we drew the area to the right of 1.19. Okay, here's what I mean. If you do it what I call the long way, you're going to look up negative 1.19, and remember that goes this way. So when you look up negative 1.19, you get 0.1170. You should realize that doesn't make sense because when you have your 0 in the middle, there's 50% on each side. So the fact that we want to be right of a negative z-score, you know your answer has to be greater than 50%. Okay, so 0.1170 is to the left. We want to find to the right. Well, your total is 1, so you just need to do 1 minus 0.1170, and that gives you 0.883 for your final answer. Okay, so that's what I call the long way, where you look up negative 1.19, figure that out, but again, that's to the left, and we want the right, so then what you do is you just have to subtract it from 1. What is considered the shortcut is if you look up positive 1.19, it's going to give you the 883 right away. Okay, because again, the area to the right of a negative number is going to be the same area as the area to the left of a positive number, because again, this is symmetric. Okay, your normal distribution is symmetric, so the area to the right of a negative is the same as the area to the left of a positive z-score. Again, it's different sides, but it doesn't matter because we're just looking for the area. All right, so we looked at to the left and to the right. Now we want to find the area between 2 z-scores. All right, so this time you're going to have to draw 2 of them, 1.68 and negative 1.37. So 1.68, negative 1.37. Again, I don't ever draw them to scale. I just put them in so I can make sure I have enough room to write. And we want the area between. Some people hope there's a shortcut to this, but there's not. You just need to look both of these up exactly how they are. So when you look up negative 1.37, that gives us 0.0853. And then when you look up 1.68, again, remember both of those are going to the left, you get 9535. Okay, so 9535 is from here all the way over. 0853 is from here all the way over. So basically, again, you would color this whole part, but then we need to take that away from it. So you just subtract these two. So anytime it asks for the area between, you just have to look the 2 z-scores up and subtract those 2 numbers. Don't subtract your z-scores. That's where most people make the mistake, is they subtract the z-scores. You have to subtract the percents or the decimals. So 9535 minus 0.0853 gives you your final answer of 8682. Okay, 8682 for your final answer. All right, so again, that's finding the area to the left, to the right, or between two specific z-scores. Instead of asking for the area, what we're going to do next is we're going to ask for the probability. So number 2 on your homework is like A through H or J or something crazy like that, and they all look exactly like this. Okay, so it's the exact same process, only you're finding the probability. So what I want you to do is leave them as percents. Okay, so you'll just have to move the decimal over twice. So this one, we want the probability that z is less than 1.65. So again, I'm just going to draw my curve every time, and obviously because I'm laying on the floor, it looks really, really bad, but that's why it doesn't matter if it looks right. Okay, so there's my middle, 1.65. Less than is to the left, so it looks like that. Okay, so again, when you go to look at your paper, 1.65, this picture that I drew right here matches this picture right here. Anytime it's asking to the left, it's exactly the number in the table. So 1.65, when you look that up, you get 95.05. So 95.05% is your final answer, 95.05. All right, next one. Find the probability that that z is greater than 1.91. So again, here, 1.91. So you're looking there, and we want greater than. You should know just by looking at your picture that our number needs to be way less than 50%. Okay, this one was way more than 50%. This one needs to be way less than 50%. Again, 50% would be right at the mean. Okay, so if you look up 1.91 in your chart, or when you hold these next to each other, they don't match. Okay, this one is shaded to the right, this one is shaded to the left. So again, you have two options. If you look up 1.91, you're going to get 97.19. That's this way. Okay, 97.19 is to the left. The table always, always, always gives you to the left. All right, so we want to the right, so we need to subtract that from 1. So 1 minus 0.9719 gives us 2.81% is all. A very, very small percentage that our z is going to be greater than 1.91. Okay, again, what is quote-unquote the shortcut is if you look up negative 1.91, you would get your 2.81% right off the bat. Okay, because again, this shaded area would be the same as if I drew this shaded area in here. Okay, so if you want to look up negative 1.91, you're going to get that answer right away. I will always do the long way, just for those of you that like to do the long way, but remember that shortcut is always possible. All right, last thing here, find the probability that z is between 0 and 2.32. 0 always throws people off. 0, remember, is just your mean right in the middle, and then 2.32. Okay, so we need to shade that in. So you can use your z chart to look up 0, but you shouldn't have to. Hopefully you remember that that is 0.5, okay? Because again, 0 is going to be 50%. So 0.5 there, and then you look up 2.32. Remember that gives you that amount. And you get 98.48. So 98.48 minus 0.5 gives you 48.48% for your final answer for that. Okay, so again, number 2 in your chapter 6 homework is a whole bunch of problems just like this. Okay. Last thing we need to do in in 6.1 is we have to work backwards. Okay, so now if you look at this first example, it says to find the z value such that the area to the left is 0.8907. So instead of saying here's the z-score, what's the percent or the area, now we have to work backwards. Okay, these don't seem bad right now, but in 6.2, this is usually the hardest thing for people to figure out. So here's how it works. When we draw it, you have to know where to put your line because it doesn't give you a z-value. So we want the area to the left to be 8907. So that tells you your z-score is going to have to be over here because you need an area bigger, an area to the left of it bigger than 50%. Okay, so we know it's going to have to be like this, but we don't put the 8907 on the bottom. The 8907 is this part. Okay, 8907 is that part. So what you have to do instead is what I call looking in the big part of your chart. So here's what I mean. Instead of looking on the along the sides and the top for your z-score, you have to look in the big part of your chart for 8907. And wow, I put my finger right there. Okay, 8907 is a z-score of 1.23, not 1203. Remember that 2 and that 0 cancel out. Your z-scores are always two decimal places. Okay, so 1.23. So 1.23 is your answer for that one. Okay, so again, you're looking in the big part of your chart, the area part, the probability part, however you want to think of it, to find your z-score. Find the next one, find the z-value such that 82.12% of the area under the distribution curve lies to the right of it. So now instead of it wanting to be on the left, we want it to be on the right. So we're going to have to look at it this way. Okay, so we want that to be 82.12% or 0.8212. So here's what I always tell people. Just look that up. Look up 0.8212. Okay, I know it's going to be wrong, but let's just look it up. 8212 right here, okay, is 0.92. If I put my answer as 0.92, does that make sense? No, it doesn't make sense because my z-score has to be less than 0. So 0.92 would be over here, so what are we supposed our line is? Negative 0.92. All right, so that's the nice thing about being symmetric. Just like we could do the opposite on the front, we can do the opposite here. If you look up 8212, again, you get 0.92. That should not make sense because of your picture. So all you need to do is make it negative 0.92. And there's your answer. Okay, that would be what I would call the shortcut way, or basically just thinking about it. Knowing 0.92 doesn't make sense, so you have to make it negative. The long way, what you technically are supposed to do is you need to figure out what this is. Okay, since our chart only tells us what's to the left, then that's what you're supposed to look up. So to do that, you take 1 minus 8212, and you would get 1788. So then if you look in the big part of your chart for 1788, you'll be on the negative side. Okay, 1788 is right here. Okay, so 1788 gives you your negative 0.92. So again, instead of looking up the 8212 and getting positive 0.92 and knowing that doesn't make sense, you can subtract it and find the 1788, and then you'll get your z-score like that. Okay, next one, find the z-value for an area of 9241. Now it doesn't give us a direction, so if it doesn't give you a direction, you just assume left, since that's how it normally is. Okay, so if it doesn't give you a direction, you're going to assume left. Okay, so it looked like that, 9241. So when you go to your chart and look for 9241, you're going to just keep searching and searching and searching and searching because there's no 9241. So what you have to do, if there's not the actual number on your chart, you need to find the one that's closest. Okay, so the number that's closest to 9241 is 9236. Let's see. Right there, 9236 is the closest to 9241. All right, so we're going to have to just use that one. So 143. So if it's your exact number is not on the chart, you just have to find the one that's closest and then use that number as your z-score. So 0.9236 is closest. So z equals 1.43. Okay. Last one, find the z-value such that the area under the standard normal distribution curve between 0 and the z-value is 2123. Okay, so again, it doesn't give you directions, so you have to put them in the order they give you. So you put between 0 and the z-value. So what that means, 0 again is there, and then the z-value has to be afterwards. Sorry. If it would have said z-value and 0, then you would put your z-value over here. So just make sure you put it in the order they give it to you. So again, they want this. So this part in here needs to be 2123. The problem is we can only look up the area all the way to the left. So what you have to remember is that 0 has a z-score of 0.5. So from here to here is 0.5. We need this section to be 2123. So the whole thing needs to be 7123. So that's the number that we're going to have to look up is 7123. All right, so if you look up 7123, you should get 0.56 for your z-score. Okay, so that is it for 6-1. I know it's super confusing because it's just something totally different, and there's no rhyme or reason to why we're doing it. So hopefully it will make a little bit more sense when you check out the 6.2 video. All right.